Mr. Landlord.
Yeah?
What are you smoking, an army blanket?
Never mind about that. You owe me room rent.
All right, here's $28.
$28, fine. Just a minute. You owe me 13 weeks at $7 a week, and that happens to be a lot more than $28.
Well, that comes to $28.
Did you go to school?
Yes, sir.
Do you mean to say that you can prove that 7 times 13 is 28?
Well, it's gotta be. Certainly it is, because Mr. Rabbit and I did. That's $28. That's what you get.
If you can prove it, I'll tell you what I'll do. I will give you the room rent for nothing.
You will?
But if you don't prove it, you owe me double the back rent. Is it a deal?
That's a deal.
Okay.
You happen to have any Crayola on it?
Crayola?
Never mind. I got it.
Oh, you have?
I got the Crayola. The 7 to the 28 is gonna come out 13.
That's your way.
That's my way. And it's gotta come out right. Now, first, I put down the 7.
Right.
Now, I'm going to divide the 7 into 28.
Yeah.
I put a 28 there.
Okay.
Isn't that cute? Now, here we go. 7 into 2. 7 will not go into 2.
It will not.
That's a very big 7 to push into that little bit of 2.
That's what it is.
We ain't going to hurt that little 2, are we?
Of course you will.
So we take the 2. Open your hand.
Yes.
And I put that 2 right there for safekeeping. But don't drop it and don't lose it. Now, 7 into 8.
Once.
I put the 1 over here, 1 over there. Now, we're going to carry the 7 because it's very big and it's getting heavy on my shoulders, and I'm going to drop the 7 under there. Now, 7 from 8
is 1.
Is 1. I put the 1 down there.
Mm-hmm.
Now it comes. Would you mind opening up your palm of your hand, please? I would like to use that 2. Open it up. Give me that 2. You had it long enough. I'm going to put that 2 right there. Now, 7 in the 21?
3 times.
That's right. 7 in the 28? 13. Good enough?
Wait a minute. You have to prove this even better than that. You can prove it very easily by multiplication.
You mean you want me to multiply it?
No, not multiply, multiply. Multiply.
All right. Multiply it.
7 times 13 is 28. Go ahead.
Now, first, we got to put down a 13, right?
Right.
There's a 13.
Times 7.
Times 7.
Right.
7 weeks times 13, right? 7 times 3?
21.
21. 7 times 1?
7.
7. 7 and 1?
8.
And 2 to carry. 28.
Now, wait a minute. I'm still not convinced. There's one sure way of proving this. One sure way, and that's by addition.
You want me to addition it up?
I want you to put 13 7 times on that wall and then draw a line and add them up.
You want me to put down 13 7 times?
That's right.
Let's cut them out right. There's 1.
1,
2,
2,
3,
3,
4, 5,
5,
6, 7.
Wait a minute. What's the idea of spreading them out like that?
Well, it looks like a flock of seagulls going to hit the electric poles. Now we're going to add them up, right?
All right, go ahead.
Here we go. 3, 6,
Wait a minute. Let me do the adding this time.
Come out right.
Well,
3, 6, and 9.
Just a minute. I will do the adding. Then there'll be no mistake. All right? $28 here. All right? Now,
Go ahead. If you have that question.
3, 6, 9, 12, 15, 18, 21.
22, 23, 24, 25, 26, 27, 28.
Who says math is not creative? Anyhow, let's move on to 3.4 and 3.5. This is all Algebra 1 review, so I hope that it comes a lot easier to everybody. Let's start with the formula for slope. If you recall in Algebra 1, slope is rise over run, and mathematically we write it as y2 minus y1, which gives us the distance of the rise, divided by x2 minus x1. That should be x1, sorry. That's how much you've run, okay? I included a little cartoon here. It says that you have to rise before you run. What this means is that very often people forget that the y is on top. You have to rise first, and then you can begin to calculate the run. So it's rise over run. That's how we remember it. And the slope-intercept form of a straight line is y equals mx plus b, where m is the slope, it's also the rise over the run, and b is the y-intercept, is where the line intercepts the y-axis. Standard form is the typical ax plus by equals c. So when all things fail, that's where we go to. Let's look at this definitions of slopes. There are different kinds of slopes. Negative slopes, we're talking about line J, which is right here. And line J, the slope falls from left to right. And positive slope is like line K here, and that rises, the line rises from left to right. And zero slope is where the slope is zero, and that's the horizontal line. Let me change the color to blue. So that would be the L. So this one is the horizontal line, as in line L. And then the undefined slope is N here, which is the vertical one. Okay, the way I remember it is I can relate this to my first skiing experience. I learned skiing in Japan when I lived there as a college student, and I had this wonderful instructor who was very handsome. So as I was climbing up on the mountain, going upwards, I was feeling all happy, and my face looked like this. And so I was feeling all positive. And then once I got on top of the mountain, as I'm coming down, I was falling so badly, and it was miserable. So I was feeling all negative until I finally reached the bottom of the mountain, where the slope, as you know, is zero. So I was having zero fun because I fell so much. And then thank God that there was no cliff there. If I had to fall off the mountain, I would have died. So this part is the undefined part. That's the slope there. So positive slope is the happy slope. Negative slope is the unhappy slope. And when I had zero fun, that's when I was on the floor, actually on my bottom. So that was really not fun. Okay? Let's see. We need to find the slope of these four lines. A, line B, line C, and line D. Where is D? D is right here. So D is the vertical one. I'm going to do C and D because C is the horizontal one, D is the vertical one, and you can do A and B by yourself. Okay? So because I'm asked to find the slope, and let's see what's given. I'm given 2 points, coordinates of 2 points, the x and the y's. 1 point on C is 4, 6, which is right here, and the other one is 0, 6, 0, 6. Okay, so in order to calculate the slope for C, I'm going to use MC. So I should do y2 minus y1 over x2 minus x1. So if I continue with that, if I do 6 minus 6 over 4 minus 0. Notice that the sequence doesn't really matter as long as you're consistent. So let's say if I go the other way around, I go backwards. If I do 6 minus 6 again, but I do 0 minus 6. Oh, I guess this is not a good example, but you get the idea. It's 0 over negative 6 in the blue case, and in the red case, it's 0 minus positive 4. Either one, your slope is 0. Okay, so conclusion is MC is 0, and MC is the horizontal line. This is confirming what we just talked about. Let's look at the slope for D. Again, I'm given 2 points. One is 4, 6. The other one is 4, 0. So when I calculate the slope for D, I can do 6 minus 0, which is the y here, and then the x, x coordinates is 4 and 4, 4 minus 4. So I end up having 6 divided by 0. Obviously, we cannot divide 6 by 0, so this slope is undefined. Okay? And please pause the video and finish your practice on finding the slopes of A and line B. Now let's look at postulate of slopes of parallel lines. It says that in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. You probably have guessed it, right? If and only if they have the same slope can they be parallel. And then it says any two vertical lines are parallel. So if on this coordinates I have all of these vertical lines, they're all parallel to each other. And the postulate 18 is about slopes of perpendicular lines, and this says it all. Okay, it says that in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of the slopes is negative reciprocals, meaning the product of the two numbers is -1. If the product of the slopes is -1, that's when we say that these two lines are perpendicular to each other. So horizontal lines are obviously always perpendicular to vertical lines. Okay, let's look at this one. Which lines are parallel? I have a couple of lines. I have K1 here, and I have K2 and K3. So, and then I have several pairs of coordinates given. I have -3 and -1 on K1. The other point is -4, -6. And I can do the same with K2, which is 2, 2, and then at the bottom half is 1, is that 1, -4, and then K3 I have 4, 2 on top, and then at the bottom I have 3 and -3. So from these I can find out the slopes. Let's find out the slope for K1. And I would do probably -1 minus my y2 is -6, right? My x2 is -3 minus -4. So if I do my math right, I should have -1 plus 5 divided by -3 plus 4. So I should have 4 over -1. My slope is -4. Oops, I'm sorry, I made a mistake here. This one should be 6, actually. There should be 6 here. It's not a 5, so my final is -5. Okay, now if I do the same thing with K2, I should have 2 minus -4 divided by 2 minus 1. So I should have 6 over 1. My K2 is 6. So now I know these two do not parallel. Now let's look at K3. I have 2 minus -3 and then 4 minus 3. So I should have 5 over 1. I should have 5. Something is not quite right here. Oh, I'm sorry, I made a second mistake right here. So that should be +5. The reason that I was hesitating, how I discovered my mistake, was that if M1 is negative 5 and M3 is positive 5, the shape of the lines would be very different, if you recall from Algebra 1. So clearly that wasn't the case. They should be all positive, so there's something is wrong with this one. And when I double checked it, I came to realize that in fact it's positive 5, which means that M1 and M3 are the same. They both have a slope of 5, which makes K1 parallels K3. Okay? Here is another example that says line C passes through these 2 points. Line D passes through another 2 points. Are these 2 lines parallel? So on in your packet or on a graphing paper, graph them out, look at those 2 points, and then calculate your slope, and then let me know if these 2 lines are parallel. You don't have to graph it, but I highly encourage you to graph whenever you have enough information. Put the graph out there. It really helps you think through the problems. Okay, let's look at this example here. Line H passes through 1 and negative 2, which is here. And then 5 and 6. 1, 2, 3, 4, 5. 2, 4, 6. I think it's here, isn't it? 2, no, that's here. 2, 5. Okay, I'm sorry, 5, 6. This is 5, 6 right here. So I have my line right there. This is my line H. And then it says that it also passes through 2 and 5, which is right here. Let me change the color to blue. So it passes through this blue line here. And then it's asking me to find this line, and it's telling me that this line is perpendicular to this line. So it's asking me to graph that precisely. So how do I do that? Let me undo the graphing of the blue part first. But that's the idea. That's the direction that we're headed. All we have right now is just a point, a blue point. Okay? So let's see. The first step is to find the slope of H. And since we have 2 points, we know that we can use y2 minus y1 over x2 minus x1. So we should have 8 over 4, and then that should give us 2. Now, next one, because they are perpendicular, we know that the product of their slopes has to be negative 1. And therefore, since I know M1 is 2, I just substitute M1 with 2. 2 times M2 should give me negative 1. Therefore, M2 is negative 1/2. Now, all I need to do is to use the rise and run to graph the line, because this is telling me the rise is 1. Notice that you only go, regardless, you only go up. And then, but when you run, right, rise is always rise up. When you run, you can run to the left or to the right. And your run in this case is negative 2. So if I go from my point 25 here, I rise by 1. So I rise to 6. And then I run, let me do the blue one. And then I run by negative 2. From this point on, I run by negative 2. I end up being here on the y-axis. So there is my line. There is my not so pretty line. And that line is perpendicular to my red line H. Okay, so that's how we graph it, by knowing the slope of one line and then 1 point on the second. Another example, write an equation of the line in slope-intercept form. So this time it's asking us to write in slope-intercept form. So how do we do that? We are given 2 points again, so we know we can calculate the slope. Let's go for that. Slope would be -1 minus 3 and over 2 minus 0. So I should have -4 over 2. This time I have -2, and obviously it's the line is falling from left to right, so that seems to be correct. It's a negative slope. Next, find the y-intercept. Because look at this is information given, but it wasn't highlighted. We're given that the line intersecting y at 0, 3. So the y-intercept is simply 3. In other words, in the slope-intercept form, I already found my b. My y-intercept is 3, right? So I just substitute that. And since I already calculated the slope earlier, I just need to substitute -2 for m, and I substitute 3 for b. So the equation, the equation should be -2x plus 3. That's this equation in front of us. Another example, write an equation of the line passing through point 1, -1, and is parallel to the line of this. As soon as we hear parallel, what comes to mind is the two lines have the same slope. So because we know in this example, in 5, we know that the line 1 has a slope of 2 that comes from this, right? Therefore, we must conclude that m2 is also equals to 2. Now, because it's also asking me to write the equation, the easiest, most useful one is this one. Y equals mx plus b, slope-intercept form. And I know that I already found my slope. I can just substitute the slope 2 in there. So all I need to do is to find b. And notice that we haven't used this information right here, these 2 points. This 2 point, isn't that an x and that's a y? So one set of coordinates is given. I can simply substitute the x with 1 and then substitute the y with -1, because at that point that's the x and y value and that's given. And if I solve this, I would end up with b equals -3. Now that I found my b, I can simply plug it back in here. So my final answer for this equation is, it's 2x plus -3, which is 2x minus 3. That's my final answer. Okay? Finally, last example, again, it's asking me to write an equation of the line J passing through this point, okay? But this line is also perpendicular. If it's perpendicular, we know m1 times m2 has to equal -1. It's perpendicular to line K with the equation y equals -3x plus 1. Now, if from y equals -3x plus 1, we know the first slope of the first line is -3. Now, if we use m1 times m2 equals -1, which means -3 times m2 equals -1, that will give me m2 should equal 1/3. So I found my slope already. Let me put it in my slope-intercept form of y. That's the first one. That's the y2. So y2 now equals 1/3 of x plus b. And I just need to find a way to find out b. And in order to find out b, I need to find out a set of coordinates. And of course, that set of coordinates is given right here. So if I simply plug it in, I would have y2, which is 2, and the x value is 3 and plus b. And this way, if I cancel that, I would have b equals 2. So I found my b. I have already found my m. I can simply substitute that in my slope-intercept form. So for this line, the equation is 1/3 of x plus 2 equals y. That's my final answer. Okay, so if you have questions, you can go back home and watch this video again, or if you want to take out your devices, you're welcome to watch it again, and you can proceed with your homework. Thank you, guys.